All right, started.
All right, good morning, everyone. So a bunch of exciting things have been happening in the last week alone. Last Friday, I spoke with Nicholas about them implementing a Scality or S3 compatible operator or Cozy driver. Yesterday, we had someone from Red Hat reach out on the public Cozy channel in the Kubernetes Slack, saying that they've started writing a Cozy Ceph driver. So things are definitely picking up, which is really good.
Hey, for the
And
staff, are they going to have a different protocol or S3 compatible?
Ceph has two protocols: is S3 and is Swift, OpenStack Swift.
Oh, so they're going to
Use the
does
S3.
that mean are we going to add another protocol? Because right now we have three, right?
So Swift is deprecated. Like it's not
Oh, okay.
the whole reason they added the S3 gateway was so that Ceph S3 gateway. The whole reason they added it was so that Swift can be slowly uh, uh, deprecated. Um, so
Okay.
and this is really for the OpenStack stack. I don't believe many people are on this stack anymore, though there are some people that are still using it. However, it's like all the OpenStack companies have gone out of business, I think, except just one of them, maybe Red Hat. Um, the last one was trying to remember the name, Mirantis. Um,
Mirantis isn't that a business?
Mirantis is a business. I mean, it used to be.
Is that's acquired by somebody, right?
Oh,
Yeah, yeah.
I forgot or they acquired somebody or somebody acquired. I forgot.
Mm-hmm,
There's something happening there.
mm-hmm.
Yeah.
Yeah, and then
Okay. Yeah. I was just wondering. Okay, if they
yeah, this is
going to
it's
use
going
S3, that's fine. Yeah. Okay.
yeah. So yeah, there is three compatible.
Okay.
That person hasn't joined the meetings as of yet, so maybe someone from Red Hat could invite them, um, or explain to them, or just have them reach out to us.
I have a
Are
question.
you talking about Jiffin?
Yeah, Jiffin, right.
Yeah, I think he might not be able to attend. He's on India time, so
Oh, I
Indian
see.
time might not work for him.
It's 11:30 right now.
Was this
11:30 at night there. Sorry.
is this something in like an issue or like a pull request?
Well, no, they just announced on the Slack channel that they're writing the Ceph driver. It
Hey,
would be good to
Okay.
I
hear back
wonder
from them.
if it's the same protocol, do you actually need to write different drivers for, let's say, Ceph S3 compatible, you write the driver, and then somebody else also is S3 compatible, write another driver.
I think
Is that needed for?
you would still need
Well,
a new driver. Just the spec wouldn't need to change, right?
you would need a
Yeah,
new
sure.
driver because the authentication model for Ceph is very different. It uses Kerberos by default. Um, Sorry, for the admin API, not for the bucket API itself. Um, and then the endpoints are unique to Ceph. Some of the parameters are unique to Ceph. So we'll need a
yeah.
separate driver.
All S3 compatible means is that the data access is S3 compatible. The creation, deletion of buckets and stuff is usually specific to that implementation.
Right. Right. The data path is compatible, but the control path is not.
If the control path was already compatible, we wouldn't need Cozy. We would just use use the compatible control path.
Right. Anyway, so a bunch of pull requests. I've reviewed a bunch of them, but not all of them. I'll get to the rest today and tomorrow. So first thing I wanted to bring up was Blaine brought up a good request, I think, and I think it's I think we should discuss it all together. Um, so his request was given that the protocol has a name, say S3 or GCS or Azure, and then another structure that gets filled in, which also has the same name. It might seem like it's a redundant redundant name. It's being specified twice. the first question is that a problem? And the second one is, technically, is it feasible to not have that?
Well, yeah, I think you can have like discriminated unions that where there's like a list of possible struct values and only one of them can be populated in at least in Golang and maybe at the serialization layer. And so yeah, as long as the thing that's serializing and deserializing your objects enforces a one of kind of a relationship, then yeah, you can just rely on figuring out which of the structs is filled in to know what it is.
Right. The one thing though is, so when I first looked at it, the deserialization of something like this, an empty S3 structure, leads to a nil value. So if there was this concept of a default protocol structure, then this would get interpreted as nil, and all of the others will also be nil. So if whoever is deserializing will not be able to disambiguate between a default and nil value unless you have.
Well, no, like if you get a serialized version where all of the structs are empty, then you deserialize it and they'll all be empty and you won't know what it is.
That's what I'm saying.
And that'll be an error. But I mean, but that's okay if that's an error. You just make sure that everyone that you produce does have one filled in, and you treat one that doesn't have any filled in as an error, and you stay out of trouble that way.
That would work.
Because I mean, even if you had a name field, someone could leave that blank and then you still have an error.
Exactly. Yeah.
So yeah, you have to deal with the, user gave you nothing kind of an error case. And as long as they give you something and it's not, and it's exactly one of the struct members and not two of them, you're fine. And I'm pretty sure that the serialization can enforce that, I think. Because this is what we use for like PVs and stuff. Like there's all kinds of places where we have discriminated.
Yeah, but PVs, right? Like this is a default. This empty there is in the sense, if everything is nil, we just fill it into empty there.
I guess for part of this discussion, I did look into, so the OpenAPI v3 schema allows like setting like a one of validator. One of the sort of potential issues is that if you actually use the like Kubernetes like client generator that generates CRDs automatically, those are not able to generate API or OpenAPI v3 specs that in themselves enforce the one of relationship. I think the Go serialization could still do that. I don't think
with validation. So,
right, and it also could be like a not a mutating webhook, but a validating webhook. That's the word. So there are options for that, but I think I saw the Cozy spec uses the CRD generation code, and I did do a little investigation to find out that the like one of relationship at least can't be right now put into the validation. And there has been some talk about a like, there are some like additional parameters like the x-kubernetes thing. And so they've been talking about x-kubernetes union as an option, but I'm pretty sure it doesn't exist yet, or at least like Google searches really turns it up, nothing about it.
But I really like the idea of doing it like Kubernetes does it and just relying on one of the structs to be filled in, because if you do that and have a string, you still have all of the same error cases related to two structs being filled in or no structs being filled in, and you're adding new error cases where the struct that's filled in doesn't match the string. So
right,
it doesn't buy you anything to have the string. It's just, this is just hard work you have to do the validation.
Well, I wouldn't say it doesn't buy you anything. Here's the one place where it actually helps. Passing in this field. So first of all, it's easier to read. You just go read the struct. Then parsing it, the application has to parse this structure. The application pod would have to parse this. And again, if there was a possibility where there is an empty struct, empty S3 struct being valid, you wouldn't be able to tell whether if it was filled in or if it's an error case, or if it's valid or if it's an error case. Again, this all depends on this idea that there is such a concept as empty protocol struct. I can see that being the case. Say for S3, there's a default region, there's a default endpoint. So
can we just require that there has to be at least one field in every protocol struct to avoid that problem?
I think there is also a potential option, like again, whether this is with the cozy controller or with an actual mutating webhook in this case, if there are like default values set, we could just set those defaults to, instead of being like an empty string or a 0 value, could actually specify that default, unless you think that the application itself might want to have a quote unquote default, in which case like we actually want to pass the application an empty string or something like that in all cases. I still wonder if there's a way to pass information to the application in such a way that they can see whether one of the properties or like one of the protocols is non-nil while the rest are nil, and then have the cozy controller in some way verify that not more than one are non-nil.
You showed that here, right?
Mm-hmm.
If it is set this way and nullable is set to true, then it gets parsed this way, where it's not an empty, it's not nil, but it's an empty object, right?
Right.
Yeah, that might work. So here's the other thing. So now we're asking the application pod to like if they were to do reflect at a 0 value. I'm sure there's a way to tell if using reflect package and Go if it's the 0 value or not. So do you think so the reason I bring that up is, say an application were to check which one is empty and which one is not, and it goes through the list of fields one by one, the 0 value would be true for all three.
I guess I'm trying to understand in what way the protocol is passed to the application, whether that is passed like via Golang, like is it a serialized or just direct Golang object, or is it actually passed as a Kubernetes resource?
Yeah, I'll show you. So it's actually passed in as a file, and the file structure looks like this. Give me 1 second, I'll put it up. It's right above here. A little bit above. There's a bucket.json file I'm looking for. Hold on one second.
So it's raw JSON in a file, so you can represent empty structs differently from nil structs.
There it is. Yeah, so we wanted to use the protocol version directly because then we can version it to the same version as the current API.
You're missing some curly braces in this slide.
This is YAML.
It's JSON. It says bucket.json.
YAML. There you go.
No, it's got commas in it and stuff, man, and curly braces. This is the horrible YAML JSON combination, but
yeah.
you could turn it into real JSON.
Yeah.
I see. Okay. Yeah, I think JSON can be rendered such that if something is nil, it will output like null, or I think null is how JSON.
You omit the field if it's nil, and then you give it like two curly braces if it's an empty struct.
Okay.
I think.
It can be null. Null is a valid value in JSON.
Right, but like when you're serializing a giant discriminated union, you just omit all the fields that are null and include the one that isn't.
Right, right. Assuming omit empty set are true, yes.
So yeah, I don't see a big problem here.
Yeah, I get it. Yes, that's why I think it'll be more in line with how persistent volumes do things now.
Okay.
Which is-
Yeah, there might be a little bit to prove out just to make sure that there's not the case where make sure there's not the possibility that the JSON is being rendered with multiple non-nil, even if empty structs. But it seems like it should be technically pretty possible. And my thinking is basically just that it mimics the volume sort of API spec that Kubernetes has had for a while.
Yeah, that is definitely a positive. Yeah, it's going to be symmetric with the other Kubernetes resources. All right, so coming back to this struct, so this all depends on this idea that we can't have complete no value is not a valid value. I think that might be the case actually. So take for instance, so S3 struct today has the bucket name inside of it, and if that is empty, like in this case, you can't really do anything with the structure. So that is an invalid value if you were to go into S3. This is just one example of the fact that protocol. Maybe it's possible that protocol can never be empty. But I wanted to bring up one important question here. Say, so all the different protocols have a bucket name. So my question is, why do we have bucket name inside of the protocol rather than at this level?
Because we don't know if every future protocol will also have a bucket name.
Do we really not know, or isn't that a fair assumption to make that all of them will have a bucket name?
Yeah.
Or some identifier for the bucket?
Yeah, I would say like 99% chance that's probably true, but like we don't lose anything by pushing it down a level. And what we gain is the flexibility for somebody to do something wild and crazy.
Give me an example of that. I'm just trying to understand because I'm not able to imagine a situation where you don't have a bucket name.
I mean, imagine a system that always identifies buckets by number or by UUID or.
No, there's still an identifier for the bucket.
Right, but maybe it's not a name. Maybe calling it name is inappropriate. And for that particular protocol, you're supposed to call it the bucket number or the bucket ID or whatever. I mean, it's just, why constrain what a protocol is allowed to say is useful in that protocol by forcing everyone to have a bucket name? When it, just pushing the bucket name down into each substructure creates exactly the same amount of JSON. It's just at a different level in your structure.
One could argue, for example, that CDMI does not have the bucket name concept.
So what doesn't have it?
CDMI, which is a not very widely used, but still object storage protocol.
I see.
And it doesn't really have an a bucket name.
I see. So it's like a global namespace of objects.
Kind of, yes.
I see. All right. So I'm glad that we brought this up then. So if bucket name has to be there or some form of identifier for the bucket, can we all agree that there should be some identifier for the bucket in every protocol structure?
Yeah.
Okay. Yeah.
I mean, because the whole point is, well, we're providing something from Kubernetes to the app so that the app knows what to do. And if there's nothing to provide, then we're not adding any value.
Well, I'll play devil's advocate to what I just asked. Just like he just said CDMI, which has the global namespace. So there's no concept of bucket there. You just need an endpoint and, you're good to go.
Right, but you need something. And whatever that something is what we put in the protocol. And it may or may not include a bucket name.
I think, I mean, for me at least, I think the biggest argument to having the bucket name be inside each individual protocol is sort of like nomenclature that different protocols might use, that like all protocols will want something to be an identifier, but not all protocols will use the term bucket necessarily. Like some might use like container or like ID or whatever. So I think that flexibility then makes it more straightforward to just kind of like map from a protocol to the COSI standard when there's not a possibility of having to translate, well, like hash in this protocol translates to bucket name in the COSI spec, if you can just have hash in the protocol itself.
I see. So we are, okay, so I'm trying to, kind of get my thoughts around, wrap my head around this. And so we do abstract on, over this concept of bucket in terms of provisioning and, granting access. It's all around this concept of a bucket. So on one hand, I can see that being, wouldn't that argument apply there also? But on the other, this is going to be user facing, and we can expect the vendors to convert their concept of whatever into a bucket, but it's a little more difficult for the application writer to do the same. So with that argument, I can see this being the right choice. Does that make sense?
I mean, the other argument is I can't see any justification for wanting to force bucket name up to another level. Like, there's no benefit there.
Oh, sure. I mean, like, again, the reason I was bringing that up is there any field inside of the protocol? If it's common, why can't it be here at all? Why can't it be here? We just, discussed why not. It was more of a question rather than.
Oh, okay, yeah.
Yeah.
I mean, if there was something that was truly common, then we would hoist it up. But I think we're saying there isn't anything that's truly common, so let's not do that.
Right, as of now. Yeah. Okay, so that makes sense. So we're going to remove the version field as we discussed last week, right?
The top level version field.
Right.
Although I didn't see any feedback to that suggestion on the KEP. I just saw Jeff agreeing with me.
Do you want to give it a few more days, maybe until Monday or something?
No, if there's no disagreement, let's remove it. And then if somebody comes back in and says, no, we need it, then like, let's have that discussion and put it back if we change our minds.
Yeah.
Yeah, that's fair, Ben. I'm just looking, I guess the review's just going to be very light on the KEP at this point. And so maybe it's just good enough. There's several commits in that KEP. And, when Sid thinks it's good enough to merge, we can squash and merge it. But I will take out our, no, I'm sorry, I joined the meeting late. I had another meeting that ran long. What, can you remind me, Ben, refresh my memory, which field were we talking about?
The version that was at the same level as the bucket, or at the same level as the protocol, because we need signature version inside S3 to discriminate between like S3v2 and S3v4 and a potentially future S3v5.
Yes.
That could be relevant, because the only alternative to that would be to force something like an S3v5 into an entirely new protocol, which we said we didn't want to do. So
yeah, I know the initial reason for that field being up a level out of the protocol was that we thought version might be common across all protocols. So it was a guess.
Right.
And therefore it would have been a common field, and that it might matter to a workload, right? I don't want to be on...
But it suffers from the same problem where, yes, every protocol has some sort of a either concrete or abstract version, but it's not formatted or named consistently.
Yeah.
So let individual protocols deal with it as they want. And in the S3 protocol, it's the signature version.
Yeah, we even thought, just so you know how we were thinking at the time, that, you know, the bucket class would have the version for the protocol as well. So if the workload's version, so the workload says bucket class, you know, foo, and the workload and bucket, well, let me think. Version isn't in the BR, right, Sid?
It's not in the BR, but it
Yeah.
is in the BC that the BR
Yeah.
points to.
Yes. Never mind. I was going down the wrong path. Ben, I'm okay with taking it out. And I understand your philosophy of, you know, if we're in doubt about a field for alpha, it might make more sense not to include that field because it could always be added later. And maybe it's harder to remove a field.
It's impossible to remove fields typically.
Yeah.
So
if there's any doubt about a field, maybe our action should be to remove it, at least at this point.
Yeah. I have another question here. I think we briefly touched upon this, but I don't know what the final conclusion was. Did we talk about making the signature version a list?
we talked about it, but I think what we settled on was it should not be a list. It should just be the highest version.
Yeah. Yeah, I remember that.
And then the idea is the client could attempt to negotiate down if it knew how to do that. But this is the server's way of telling the client the highest version that it knows how to talk.
Right.
And yeah, so in the future where there is like an S3 v5, presumably everyone will also support S3 v4 for backwards compatibility, and clients can just try it, and it might work until S3 v4 becomes so old that people start dropping it, which would probably take many years.
Right.
What if there's a protocol that allows for multiple kinds of authentication?
Yeah, like so for that protocol, you probably want to have a list or a struct with the keys and keys and values, so that you could express that. But for I think most people understand S3 signature versions, like they don't change very often, and we've been on 4 for a very long time. And while 5 could show up, it would be surprising if it did. So
yeah, okay, so this is specific to S3, and other protocols could have their own struct. I was mistaken as to where this field goes.
Yeah, this is an S3 specific thing.
Okay.
Right.
And
go ahead, Ben.
I was just going to say, and other protocols, could have whatever they want. They could have a version, they could have a bunch of capability fields, they can, whatever makes sense within that protocol that the workload and the server need to agree on.
Right. Yeah, makes sense. All right. So one more thing is, someone from S3 we understand quite well, but GCS and Azure, either someone from the GCS and Azure have to come in and pitch in, make sure we get the protocol structs right, or one of us should go do the research and figure out what should go in there. We did the research upfront early on, but the amount of time we've spent on S3 is much higher than what we've spent on the other two. And I think the other two also needs the same amount of rigor. So yeah, so I'm just stating it here. I've reached out to the GCS and Azure people, until they arrive, until they come and start working on this. Yeah, one of us will have to go and understand how the other protocols work, because one, it'll help us to have much more informed conversations about these fields. And also it'll make sure that we're not making a design choice that wouldn't work with one of the protocols. Yeah, we'll figure out who and what needs to be worked on later on. I'm just stating it here. So
yeah, as I think about it, though, I feel like that's the kind of thing where it's okay to screw it up in the alpha, because the point of the alpha is to get the framework out there, to get people using it, to
Mhm.
make sure that your primary use case, which is S3, is working okay. And then if people come in and actually start writing drivers and say, wait, the GCS is all screwed up, you say, oh, well, it's alpha. We'll just fix it.
Yeah, that's a fair point. Yeah, and yeah, that does make things easier. All right, so going to the next thing. Okay, so I'll kind of talk about the bigger picture of going into the protocol fields right now. So one of our main goals right now is to do the API review and pass the API review test. For that, we should all be in agreement about what the different fields are and how they're supposed to work. Once we have that, we can go update the KEP and have Tim take a look at it again. And that's what we're working towards right now.
Isn't the big sticking point with the API review like the namespaced and non-namespaced one-to-one binding?
So assuming bucket mutation was something we were going to support, then that was the issue.
I heard Tim sort of suggest that he just didn't like the namespace and non-namespace object binding to each other, period.
So
Because it's not just mutation, it affects how you share across namespaces too.
self-service, right?
Huh?
It affects self-service, right? Because you can't actually update the object even though you're the one who's created it.
I don't know about that.
When you map from bucket request to bucket, namespace to non-namespace, you end up in a position where you can create the bucket, but you can't update any. Okay, yeah, bucket mutation is not allowed right now. So,
but I mean, I think there's ways to address sharing that involve just more controllers and more automation, even if we stick with our current BR is namespaced and B is not namespaced. But like, I still want to hear what the alternative is. We never, as far as I know, the network guys never showed up and told us about their design.
Not yet. Let's reach out to them one more time, maybe. Maybe we'll have Tim also join us another time. But yeah, aren't we following the same model as PVCs and PVs?
No, like Tim said clearly that what the path they went down with the network, whatever it was, and I even forget what the object name was two different namespaced objects that bind to each other.
Yeah, network gateway. So it was something like there's going to be
gateway.
Yeah, it's going to be something like a namespaced pair, like network gateway request and network gateway. I don't know the exact names, but something like that. It's equivalent to how cluster roles and roles work. So there's a cluster role binding and there's a cluster role. There's a role and a role binding. One is namespace, one is not.
Okay, I thought I had heard that as I heard that suggestion. I didn't know that was what they had done. So then the idea is, if you're creating buckets for use in your namespace, you would just create the namespaced object and we would keep it in your namespace forever. But the moment you wanted to start sharing across namespaces, you would create a different object, which is like a clustered bucket.
Mm-hmm.
And then everybody could see it.
Yeah.
And everybody could use it. But it's a whole different object because it's intended to be shared.
Mm-hmm.
So like
exactly. So the idea is there are some resources or some teams that'll manage buckets that span across namespaces, and then some teams that'll manage buckets that are only local to them.
So that would be a huge design change, and that's the main thing that we would need to sort of decide whether we like or don't like before we would do another round of API review. Because if we go down that path,
everything
changes. Yes.
Right.
Yes.
Right. And on one hand, I can tell you, as much as I don't want to do it, I can tell you that this is the last chance we'll probably have to change. So if you're going to consider it seriously, we should do it now. I mean, even have the discussion seriously. I mean,
have you guys spent any time thinking about it, like, deeply?
So sorry, go ahead.
I haven't given it more than like 5 minutes thought.
I did find some issue with it. I can't remember. That's the problem. Because see, if we go down that path, there are all the different concerns we had earlier have to be addressed again. And with the current approach, maybe it's not perfect, but it addresses all of the different concerns that we have, including portability and stuff like making sure that it's idempotent, declarative, whatever else we care about. We just have to go through those the same rigor we did last time. And if we find any issues, we have to see if there's a simple way out of it with the new solution, or if it's too complex, we can let it go. I do remember doing this exercise once and finding that there was some problem. I can't remember what was though. Maybe we can do it again.
The exercise of considering a clustered bucket resource.
Yeah.
And I'm trying to think about it now, and I just like the main difference is that you would never have a need to clone the bucket object, right?
Well, you kind of have to, because how do you share a bucket that's been created within the namespace?
Well, so if you had a bucket that was created in a namespace and you decided, you know what, I want to share it, I think what you would do is you would delete the bucket request and the bucket and replace them with a clustered bucket request and a clustered bucket. And that would be your migration path from greenfield to brownfield. And if you wanted to start off in I guess the question would be like, can I make a clustered bucket request and do like a greenfield shared bucket? So like it's begins its life as a clustered bucket.
Always there, and
it's always visible to everybody, and then everyone can just refer to the clustered bucket request, which is visible to everybody. And you have to do RBAC on it to prevent the wrong people from deleting it or doing things to it. And I guess and if you started off as an ordinary bucket request just within your namespace and you just changed your mind, the migration path would be you could delete those and replace them with equivalent clustered resources, or an admin could do that. So the admin would be required to fix mistakes. But if you always want to stay within a namespace, you could always use the namespace object, and you never need to clone the bucket. And if you make the right decision up front and say, I want to make a shared bucket, then you just immediately start off with the shared model and you'd be okay. And the big downside that I see is you basically have to double your objects, or at least double the bucket request and bucket objects. I don't know if the what the BAR and the BA objects, how those would change in such a world. But one could imagine allowing those to point to a clustered resource instead of a namespace resource.
If we did that, there's no difference between what we have now and in that model, except sharing. There'll be only one bucket in the clustered namespace rather than n copies of the bucket.
The difference I see is that like you double all of your code that has to handle buckets, right? Because you have to have an if namespace bucket, else if clustered bucket.
You can have two separate controllers. That I don't.
No. I mean that's the thing is when you think it through, you need one controller because you only want one instance of the Cozy plugin, but that one controller would have to have special logic to deal with namespace buckets and non-namespace buckets. And I mean, it would do the same thing, but you'd have to have all these if statements everywhere because the API objects would be different ones.
Well, I mean, I maybe what Sid was saying is that the like Cozy controller itself would have two reconcile loops, and one reconcile loop would be for namespaced, and one reconcile loop would be for non-namespaced.
Yeah. I mean, at the very top level, it's two different objects that are being watched and two different event handlers. But like very quickly, they're going to fold into using the same code to actually do the work. It's just that there's going to be, if it's a clustered one, you have to make sure you work on the clustered object. Otherwise, you work on the namespace object. But all of the interactions with the Cozy driver don't care, right? Once you get down to that layer, it's just a bucket.
Right. Okay. But the shared code, at least some parts of the shared code, are likely to be like, well, we don't want to duplicate the code itself, and so the code will have some if statements about
right
namespace versus IC.
That's why I'm saying like it's going to double part of the code and not the rest of the code, but it is higher effort in terms of the number of API objects you have to deal with and the number of lines of code you have to write to do that. But but it does have that positive result that, you know, no one's ever going to go around deleting these, or no one's ever going to go around cloning the buckets, and it makes the cleanup problem a lot less annoying, I think.
I'm not sure. Good.
I'm just, so I'm, you know, my background is from the volumes and snapshots, and I think a lot about, you know, because we've done the thing with snapshots that we proposed doing for Cozy here, where we have, it's always a namespace thing. And I was wondering, like, what if we had decided to also allow non-namespace snapshots in, you know, when we did the snapshot work, like what would that change? It would make it way easier to share snapshots across namespaces for one thing.
Mm-hmm.
Creation of them would be really weird because volumes are namespaced, and yeah, you need a way to sort of go from a namespace volume to a non-namespaced snapshot, and that would be complicated. So that's probably why we didn't trod that path with the snapshot design. But I don't know, I find that at a high level appealing, and I think that we won't find the showstopper issues until we roll up our sleeves and
Right.
start changing everything and walk through all the workflows and then say, oh, this is going to be nasty, you know.
Yeah, I'm afraid of that too.
But
and also there are some obvious questions that are unanswered. Like, I don't see a big benefit of that over what we have. I mean, it's maybe there's a small benefit, but I don't see something compelling.
the biggest benefit that I see is that a non-administrator user could easily get access to a shared bucket that somebody else owns, right? Because in the model we have now, you either need an administrator to come in and clone the bucket for you so that you can get access to it in another namespace, or at some point we're going to have to write a controller and its own, and that's going to have some sort of a new object that drives its behavior so that you can get access to, and then when we write that new controller, or when we go through this process, we're going to be faced with a bunch of RBAC issues, and we're going to have to think it through. And it's like, if you just go with the clustered bucket model, like, you can lean on the existing RBAC system and say, well, you know, it's a different object, so, you know, when you set up your roles, you have to decide if people can access clustered buckets as well as buckets, and force them to use the existing RBAC system to make those kinds of decisions. Like, again, I'd have to think very carefully about, like, how dangerous is it to give a user clustered bucket access?
Right.
You know, can
also,
they wreak havoc if you do that?
Also, do you mean like RBAC per resource, like per bucket, like you choose which bucket is accessible from which namespace, or do you mean RBAC for the bucket itself, like the whole concept of buckets, bucket type?
Well, I'm presuming that, like, ordinary default users would automatically create access for things like bucket requests.
Yeah.
But it would not be typical for ordinary users to create access for clustered bucket requests.
Right.
And it would be a special role that, you know, the guy who's allowed to create clustered buckets would be an elevated privilege that you would give to only people who you want to be able to do that. And then the question becomes, like, how dangerous is that role? Like, what can someone with that role do? I guess they can probably delete other people's buckets, which is a little dangerous. So maybe you'd have to say, you know, only give it to people you trust.
But in our model, so for a bucket request to be able to specify a bucket, it doesn't need to have RBAC. Any kind of policy is saying you can, you know, this.
Oh, but you need to have the role that lets you create, list, delete, modify BRs and BARs.
That's, yeah, but that's within your namespace. Yes.
Right. And if you want to, and if you only have that level of access, you can never clone a bucket to somebody else's namespace. Like, somebody who has read, write, create, and all the other accesses to the bucket, the non-namespace bucket object, has to come in and help you. And
right. Or a controller.
Or a controller, but that just sort of punts the RBAC decision to the controller. And now the controller has to have a security model.
Right. The controller needs to have, you know, RBAC to be able to move, you know, create clones of the bucket. Yes.
So the benefit of the clustered object model is that you can only you can give certain users the ability to create these special shared buckets and control that. But once they are created, you can give other people access to list them and get them without modifying them. And then that's all they need to be able to bind to them, right? If I can list all the clustered buckets, then I can create a BAR in my namespace that points to a clustered bucket and create a pod and then obtain access to the bucket without the need to create any non-namespaced object. That would be the benefit.
Why do we have multiple buckets today? Why can't we do the same with the existing approach?
If I have a bucket that I want to be available in both Alice's namespace and Bob's namespace, the model today is I create two Bs and then I create two BRs, one in Alice's namespace and one in Bob's namespace, but both of the Bs are non-namespaced, and somebody has to create two of them, not just one of them. In the cluster model, you'd only have to create one clustered B. And then you could walk away, and then Charlie could come along and he could get access too.
No, I'm asking why can't we do that with the current thing where we, instead of saying we have multiple Bs, we have only one B? What was the reason we chose?
It's the one-to-one binding thing. Like
but going back to the other model, don't we have the same many-to-one problem?
No, because the clustered bucket request would bind to the clustered bucket one-to-one.
And then how does it become? How does the namespace access it?
You just refer to the clustered bucket request, which you're allowed to see.
Okay, from the
namespace.
Okay, so you'll be allowed to see the cluster bucket request, and you'll have multiple bucket requests pointing to the cluster bucket request, correct?
No, BAR is pointing to the clustered bucket request. Because you don't need another BR in that case. You can see the one that exists, so you just directly use it. You might not be able to modify it or change it, but you don't need to, because all you want to do is access it.
Mm-hmm.
So I mean, we only have 10 minutes left, and this is a huge topic, but having thought about it for 10 minutes, I don't hate it, but it's just it's going to be a lot of work.
Yeah, no, I don't think it's worth it at this point. But I know it's good that we started the conversation. I think this was something we should talk about once, and really, again, if there is something that is very hard to do with our current approach, it'll be good if we've discussed this and we have a good sense of what the trade-offs are. Because we can bring it back up if there is some step, if some point we reach where we're like, okay, we just can't solve it with the current approach. Unless otherwise, I don't know if we should go back to square one, to be honest. Now, again, we need a very good reason to make such a huge architectural change.
But I mean, the best reason that I think we have available is that Tim Hawkins seems to regret the PVC model, and he likes this network gateway model.
Yeah, that's
and he's the guy who has to approve the API.
Yeah, he's flexible though. That's one. The second thing is I keep going back to the PVCP model. The PVCP model is difficult because you're trying to do a two-way binding between PVCs and PVs. In our case, we don't have that double coupling kind of thing. We just have one way.
No, it's two-way bind. It's always been a two-way bind.
No, sorry. Not the two-way
race conditions otherwise.
Right. The PVC-PV problem is two-way binding with the matching. So in the sense, when a PVC is created, you don't know if there are other PVCs contending for the same PV that you're trying to get to. So what happens is you create a PVC, you try to match it with one PV, you start by matching with it, and then some other PVC ends up also trying to match with it. There's a race condition there. Only one of the requests or the updates to the PV succeeds. You don't know which one, and they try to match back to the PVC.
Well, you do know which one. It's first past the post, right?
Whoever wins the race, you mean?
Yeah. Somebody will win the race, and you'll know who that is after he wins, because it'll get, the PVC will get updated and point to that one, and the guy who loses the race will attempt to update it and fail, and then that PVC will just
So the way it goes is the PVC will look for a volume, and then the PV is updated to point back to the PVC first.
Yeah, my understanding of the reason why the PVC PV design has become much hated over time is because it was originally designed not for dynamic provisioning use cases, but for static provisioning, where you had sort of a bunch of PVs out there statically provisioned, and the only problem you were trying to solve is like, which one do I get? And then when we moved to dynamic provisioning, we didn't rewrite the API. We tried to sort of graft it in, and it works, but it's a little funny now because of that history. And
yeah, and you don't have this. Right now with the matching thing, you don't know which volume you're going to get. But with dynamic provisioning, it's not the case anymore. So it's predictable.
Well, yeah, it's because you're not trying to grab a specific bucket. You just want to create a bucket.
Right. Exactly. So I don't think the PVC model, by just because of the way it is inherently bad or wrong. It's just for that use case. It's not the right way to do it with Kubernetes. This whole matching business.
But I feel like the thing that Tim said irritated him was the fact that the PV was non-namespace. Like, what if the PV was namespaced?
What do you get?
As long as you're only doing dynamic provisioning, you would be fine, right? Because every PVC you created would result in a PV in your namespace. And because you didn't intend on sharing that with any other namespaces anyways, it's fine that it's in your namespace. The whole point of PVC being non-namespace is based on the static provisioning assumption that there's a pool of stuff out there that is shared, and you don't know which namespace each volume is going to end up in. So you need a non-namespace PV to represent them. And once they become bound, that sort of puts them effectively into a namespace through the binding. But if you were doing dynamic provision, you could have just made the PVs also namespaced, and you would never have had any problems.
Well, you also originally had this idea of reclaiming a volume, and then once you are recycling a volume, and then once it was recycled, someone else could use it.
Right, but that goes back to the static provision. I mean, that's a static provisioning way of doing things.
Well, also that also plays into the whole sharing business. But now that we don't have it,
well, but PVCs are not meant to be shared.
On PVs themselves. Oh, you're saying because it's dynamically provisioned, you don't.
No, but just because in general, like you can't have multiple pods attached to the same PVC, or if you can, because it's like an NFS volume, they're still probably going to be in the same namespace.
Yeah, that is. I'm not sure. I mean, like, I'm not doubting you, but
I'm sure you can come up with cases where you do want to share it, but like those are special and not the main situation, I think.
Right.
But buckets, I think it's much more obvious that they're likely to be shared, right? We spent a huge amount of time talking about the brownfield shared bucket use case because that's almost the common one. And
yeah, it's always read write many. Yeah.
And having a clustered bucket request and a clustered bucket, and of course, I guess the other corresponding changes are BRs and our Bs would both become namespaced. So the Bs would no longer be non-namespaced. You could just have a namespaced bucket, and you might not run into any trouble. I mean, we'd have to think that through, but I think that was the claim that Tim made. And again, I haven't thought about it enough to know if it's true or not, that it's better to keep everything namespaced, unless you literally want to go the clustered route where it's shared amongst everybody.
Yeah, but then RBAC can't save you there. You can't like, you'll always need to have an administrator come and figure it out for your namespace.
For what?
If everything was just namespaced. Sorry, if everything was non-namespaced or clustered.
No. Your buckets and your namespace buckets would be completely namespaced. There'd be no non-namespaced objects. And then the shared buckets, which we'd have to, I don't know what we would call them. I've been saying clustered bucket, but I hate that name, so I should stop saying it.
Yeah.
Say like
So
shared bucket or something would be
good.
the shared bucket would be the non-namespace one that would have, you know, the same semantics but without the namespace, and there'd be different RBAC on it.
So this, yeah, there's one more. So I want to kind of bring up one distinction between network gateways and buckets. Network gateways don't have this concept of sharing whatsoever, because network gateway, the idea behind it was you have some gateways, some network paths that are managed by central, organization level team, like a admin team. And then there are some that are managed by the application team. You don't generally have that concept there of this a shared network gateway where you need to have different forms of access to that shared network gateway, unlike buckets. I think given that network gateways are more transient in the sense that they're not holding any space, they're not alive once they're deprovisioned, and they don't mean anything once they're deprovisioned, or once someone stops using it. I think it's I don't know if that model exactly translates here, because you could say the same thing about cluster roles and roles also. There's no concept of sharing there. Someone else isn't going to want that role from another namespace. It can be created on its own in your own namespace, have the same rules, same policies, but they can be two distinct objects. They're not referring back to the same central role.
Yeah. I don't know. I'm gonna have to